Hello, students. Our last day talking about area of quadrilaterals, and we saved the best for last. The last one is a trapezoid. So here's all the formulas that we've talked about so far for area of quadrilaterals. We talked about a square. The area of a square is base times height. Another way to think about that is to find the side and square it. Area of a triangle is the base times height divided by 2, or half the base times the height, because a triangle is only half the space of the rectangle or the square. Area of rectangle is base times height. That's how you find out the number of squares inside a rectangle. If you have, wow, bad rectangle, 2 times 4, okay, the area is going to be 8. So area is really related to multiplication, which is why all of these formulas have multiplication in them. Area of a kite, that was a fun one. This is one of my favorites. Half the diagonal 1 times the diagonal 2. Remember what a kite looks like? Two triangles reflected over a line down the middle of the kite. Whee. A rhombus is also 2 triangles reflected. It's also half diagonal 1 times diagonal 2. You could also see that the rhombus is made up of 4 perfectly congruent triangles. So you could also add up the area of all 4 triangles. And then area of a parallelogram we talked about was the base times the height. And the height has to be perpendicular to the base. Now we're going to do trapezoids. So what is a trapezoid? Trapezoid is a quadrilateral with 1 pair of parallel sides. In England, they call it something different, which is weird because we both speak English, but they have a different name for this shape. So we can look at these. Some of these are actually special. Here is the parallel sides, and these sides are parallel. Remember, the parallel mark is just that little arrow at the end or somewhere along the side. Okay, and these are parallel. So this one has a special name. It's a trapezoid, 1 pair of parallel sides. It's a quadrilateral. This angle is what? Probably a right angle. Now that I put the box in it, it's definitely a right angle. So we call this a right trapezoid. That makes sense. All right, this one's not special, but this one is special. What if this side and this side are the same? You guys remember what a triangle is called when it has 2 sides the same? Yeah, this one is special. It's an isosceles trapezoid. Isosceles trapezoid. Trapezoids are named like other quadrilaterals by the letters around them. So if I wanted to say, hey, look at the right trapezoid, you would know to look at this one. If I want to say, hey, look at the isosceles trapezoid, you would know. What if I want you to look at this one? I could say, look at trapezoid TRAP, and your mind would look over here. This is how we would name this, TRAP. Another thing that goes with trapezoids is the sides that are parallel are called bases. So every trapezoid has 2 bases. It has a short one and a long one. And it doesn't matter which is which. I'm going to call this, so we usually just do B sub 1 and B sub 2. So that's base 1 and base 2. Base 1, that's how we would say that, and base 2. Okay. This one also has 2 bases, base 1, base 2, and base 1, base 2. Where are the bases on this one? Is this the base? Just because it's at the bottom doesn't mean it's the base. The bases in the trapezoid are the ones that are the parallel. So in this orientation of this trapezoid, these are the bases. I could call this base 1 and this base 2. Okay, and we need that information in order to find the area. The bases are going to be an important part to finding the area. Another thing that trapezoids have is a height. So the height of the trapezoid is the distance, the perpendicular distance between the two bases. So I could measure it straight down the middle. We usually measure it from a vertex to the base. Okay, so I need to know how long this is. This is going to be the height of the trapezoid. Again, I could measure here or straight down the middle. Maybe I'll be a little weird and measure it here. This distance right here is the height of the trapezoid. Hey, where's the height of this one? Oh, this one's a little tricky. I don't know if that's a right angle or not. Let's say it's not. Okay, the height would be actually right here. It's kind of strange. You might think it's this because this is how tall it is, but the height is the distance between the bases. I'm going to write that down. The height of a trapezoid is the distance between the bases. The height of a trapezoid is the distance between the bases. Okay, so how do we find the area of these things? Well, we can just play around with it. So we have it on graph paper, so I could start counting the number of squares inside. I also want to look at how long the bases are and what the height is. For a right trapezoid, there's a couple ways to find the area. What I would do probably is, let's count this up first. 1, 2, 3, 4, 5, 6. 6 units for the base on the top. And that sounds kind of funny. And 1, 2, 3, 4, 6, 7, 8 units for the base on the bottom. Now, if I multiply 6 by 8, that's not going to work. That's way too big. Okay. What's the other piece of information I need here? I need the height. So what's the distance between the bases? 1, 2, 3, 4. Now my brain, if I don't know the formula for the area of a trapezoid, because I haven't done it in a long time, my brain is like, okay, well, I'm just going to divide this up. I'm going to put a line right down here. Now, why is that smart? Do we know how to find the area of that shape? That's a rectangle. Do we know how to find the area of that shape? That is a triangle. So if I want to find the area of this trapezoid, area of the trapezoid, I'm just going to put TRAP. That's going to equal the area of the rectangle plus the area of that little right triangle. Okay, what's the area of this rectangle? Is it 4 times 8 or is it 6 times 4? This rectangle is 6 times 4. So the area of that rectangle is 24 units squared. 6 times 4, 12, and 12 is 24. Okay. What about the area of that little triangle? Well, the area of that triangle is half the triangle's base times the height. Do we know the base of the triangle? Well, if this part is 6 and this whole part is 8, so here's 8 and I take off this 6, that's 2. Okay, and you can see this has 2 units along the bottom. And this is also 4 units. So what's the area of this little triangle? It's half of 2 times 4. Half of 2 is 1. This is a little review. So that's going to be 4 units squared. Okay, now we're going to add that together, and that will tell me the area of the trapezoid. 24 squares plus 4 more squares is a total of 28 units squared. So that's one method. Another way we could, let's look at this one. What kind of special one is this? This was a right trapezoid. What's this one? Are these two sides the same? Yeah, so it's 1, 2, 3, 4 along the top. We'll call that a base. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 for that base. Okay, now I don't know the formula for area of a trapezoid. I forgot. We'll see if I can remember in the next slide. But I can see that if I drew this little line right here and this line right here, hey, now I know some shapes. What shapes do you see here? I see a rectangle and I see two triangles. So the way I could find the area, let's call this one QRST. So if I want to find the area of trapezoid QRST, I can write my own formula. The area of QRST is going to equal the area of that triangle plus the area of the rectangle in the middle plus the area of the triangle on the other side. That's a weird formula. We can use it. Why not? QRST. So what's the area of this triangle? First thing we probably want to do is figure out how long this is. If the whole thing is 10 and this much is 4, then we're going to have 3 on either side. Maybe I'll change colors. You know, 3 over here and 3 over here. Does that make sense to you? I hope. 3 plus 4 plus 3 is 10. Okay, we also need to know the height. So let's find out the height. It's the height of the triangles and it's the height of the trapezoid because it's the distance between the bases. It's 1, 2, 3, 4, 5, 6. 6 units. Okay. So what do we know? We know the area of the triangle is 3 times 6 divided by 2. What is that? 3 times 6, 18 divided by 2 is 9. So the area of that triangle is 9 square units. And what about the area of the rectangle in the middle? We have 4 by 6. That's a 24 again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 20, 22, 24 squares in there. 24 squares. And the last piece. That triangle is the same size, isn't it? Yes, it is. So it's also 9 units squared. Yeah, so I can add that up. And I have 24 and 10 is 34, 44. If these were 10, this would be 24, 34, 44, but they weren't 10, they were 9, so it's going to be 42. Wow. And it's squares. I'm counting the number of squares and things. When you add squares with more squares and you keep adding squares, you end up with a whole bunch of squares. All right, this one. Now, this one is a bit annoying. I could do what we did before and break off these little triangles. Okay, but it becomes even more challenging because now I have to find the area of this little triangle and the area of this triangle, and now I'm just wondering if there's a formula. So let's see if we can figure out a formula for this. We know that we have the bases, and we know we have the height. So one way people came up with these formulas is to take this shape and transform it. There is something really interesting about this line right here. And someone really smart said, if you, this distance here is actually called the median of the triangle. So I'll use black. 1, 2, 3, 4, 5, 6, 7, 8. It's 8 units for one of the bases. And it's 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12, 13 units for another one. This line I just drew, this line segment is called the median of the trapezoid. And it's actually halfway in between the bases. So it's actually the average of the bases. So if you add 8 and 13, 13, 14, 15, 16, 17, 18, 20, 21, 21 divided by 2 is 11 and a half. So this is exactly 1, 2, 3, 4, 5, 6, 7, 9, 10, 11 and a half. I think I did that wrong. 21 divided by 2 is 10 and a half. 18, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, 10 and a half. Haha. Okay, so we have, so the median is 10 and a half, the average of the bases. Now, someone really smart thought it would be cool to reflect the trapezoid over this line down the middle, this median line, and then translate it over. So this 8 units for this base would flip down to here, and then we're going to move it over, and we're going to put it right here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the reflection, and we put it over here. That base, we'll call that base 2. Okay. This base gets flipped up to the top, and then we're going to translate that over to the right. And it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, and then the rest of it comes with it. So what did I do? I flipped this thing over, translated it, and stuck it on next to the original. So this is a reflection and translation of the original trapezoid. Now, why is that smart? This is 13. We took a shape that we did not know the formula for, and we turned it into a shape. What shape is this? What is this big shape right here? That is a parallelogram. Do we know the area of a parallelogram? Sure, it's base times height. Let's go put the height in here. I'm going to use this as the height. You can count it. We're finding the area. It's 1, 2, 3, 4, 5, 6. The height of the trapezoid is 6. The bases are 6 apart. Okay, so this is where the area formula for a trapezoid came from. You have the area of the trapezoid, and the original one, that is half the area of the big green giant parallelogram, right? Because the part that we want is half of the parallelogram. Kind of cool, huh? Do we know the area of the parallelogram? Well, a parallelogram is base times height. So the area of this parallelogram, we'll do it this way. The area of the trapezoid is half. And then this is going to be, I'm going to use green here. This is base times height. Okay, now the height of the trapezoid is the same as the height of the parallelogram. So I'll do that at the end. What is the base of the parallelogram? The base of the parallelogram is base 1 plus base 2 of the trapezoid. Okay, because it's double the distance. Okay, and then h is the height of the trapezoid and the height of the parallelogram. That's the same thing. That's the formula. That's the formula for area of a trapezoid. You want to find a trapezoid, you can reflect it and translate it. You get this giant parallelogram and you only want half of it. Okay. Now we can use that. So I don't expect you to derive this every time. You can just use the formula. So if I was going to use it for this one, the area of this trapezoid, we'll call it TRAP because that's my favorite name for trapezoids, is half the base, or the average of the bases essentially, times the height. Okay, so the area of this trapezoid is half. What's the base one? We'll call that 13. And base 2 was 8 units. And the height was 6 units. When you add units together, it stays the same. Whoa, trap. So 13, 14, 15, 16, 17, 18, 19, 21. 21 units. Units plus units is still units. Units times units is what? Units squared. When I do this math problem, because I don't have my calculator nearby, I'm going to do half of 6, because 6 is an even number and it's easy to take half of. So half of 6 is 3. 3 times 21, 3 times 20 is 60, 3 times 1 is, so 3 times 21 is 63. Units times units is units squared. All right, that's it. All right, let's apply it to one more. So here is a trapezoid. It's not a right trapezoid. It's not an isosceles trapezoid. So I'm going to apply my trapezoid formula. I'm going to call it ABCD. Haha. Trapezoid, the area of trapezoid ABCD is half the base 1 plus base 2 times the height of the trapezoid. The height of the trapezoid is 2.9 inches. That's too messy. Area, capital A for area. Area of ABCD is half. What's base 1? 3.3 inches. And what's base 2? 1.5 inches. Wow, it's hard to get those units in there. A, B, C, D. Okay, and oh, I found my calculator. 3.3 plus 1.5 is 4.8 inches. Inches plus inches is still inches, but inches times inches is inches squared. So I just have it in my calculator. I'm going to do 4.8 times 2.9, and then I'm just going to divide it by 2. So the area of trapezoid ABCD is 6.96. What? Inches times inches, which is inches squared. Okay. Be good, work hard, keep learning.